Yeah. Any idea? Just quickly tell me. Yeah, Vamsi. Amuna, what this method is? This method is acid catalyzed hydration of alkenes. Okay. So alkenes, you put water, you add water to them. That's why it is known as hydration. Hydration means what? Addition of water is known as hydration. Okay. But why acid catalyzed hydration? Okay. Why do we need acid? Any idea? Yeah, who's going to tell me? Yeah, quickly tell me. Yeah, any idea? Why do we need acid?
So because there is a presence of pi bond which is tough to go forward with, so we use the presence of catalyst.
Yeah, actually water, this is electrophilic addition reaction, and water undergoes self-ionization. It gives H plus OH minus, but very less. It's negligible, and it's just not sufficient enough to undergo reaction in a significant amount on its own. So though while writing in the book, we can write, okay, this is H plus and OH minus. Okay, but actually how much it is happening? Very less. So you need some external help. You need some help from acid. You put some acid, okay, which can give H plus, and H2SO4 is a common acid which can give H plus, right? So what you do? You put H plus externally, that acts as a catalyst, and that helps the breaking of pi bond. Yeah. So it is Markovnikov addition. Okay, so the H plus is going to come and join itself to the carbon atom, bearing more number of hydrogen. Okay, right? Rich gets richer, and actually the main thing which is governing this addition is the stability of the carbocation. Actually, you try to form a carbocation inside, okay, on the more branched carbon, because it is more stable. Because if it is more branched, it will be having alkyl groups on two of its sides, so it will be more stable because two alkyl groups can donate electron to it, right? And now the OH will come and join in. And the H plus will be removed again, and that will make OH neutral, right? Is it clear? So in this case, you need to think that this is H and this is more. So OH you are going to put on more branch carbon. So here you have put H and there you have put OH. No need to write H. And in this case, you have one hydrogen here. So you are going to put another hydrogen here. Total, there will be two hydrogen and you have put OH here. So this is Markovnikov addition. Okay, clear? So just do one question, very small question, but very important. Yeah, Memuna, I hope you are getting. And so what is going to be the answer of this? Acid catalyzed hydration of alkene except ethyne lead to the formation of which type of alcohol? Yeah. Yeah, Vamsi, tell me. Which type of alcohol we can get easily?
Option B.
Option B, primary or secondary alcohol, or is it going to be secondary or tertiary alcohol? Yeah. Vamsi, what's your answer?
So I think it's A.
Yeah, A and B are very close to one another. You need to be very. So smallest alkene is ethene. CH2 double bond CH2. Okay. If you go for any other alkene other than ethene, it is going to have more carbon atom. Okay. Like this one. This is the next higher alkene. Right? So if you have this alkene and if you put OH, you are going to get secondary alcohol. Okay. Primary alcohol is obtained only by ethene by acid catalyzed hydration. Okay, acid catalyzed hydration, actually someone may argue that this may also give primary alcohol. Someone may say that, okay, this propene can also give primary alcohol. I will say no, because acid catalyzed hydration is Markovnikov of addition. Okay, and that is going to give us more branched alcohol in which the OH group is actually inside, right? Memuna, is it clear? So you can get secondary alcohol. And suppose if you have more branched alkene like this one, so you are going to get H here and OH. So it is going to be tertiary. So secondary or tertiary alcohol we are going to get by acid catalyzed hydrogen. It doesn't mean that you can't get primary alcohol. You get primary alcohol, but by different methods. Okay, but by different methods. Okay, clear? So I hope this is clear to everyone. Memuna, is it clear? Okay, so let's understand the mechanism of this one. So what's going to be the mechanism of this one? Very easy. Can you tell me? Yeah. Memuna, Vamsi, can you tell me the mechanism of this one? Very simple. Just what you are going to do.
Sir, first H plus attacks on the less substituted carbon,
Yeah.
and then it develops a carbocation.
Yeah. This one, and that is going to form a more branched carbocation and a more branched carbon, right?
Yes.
And that will be more stable. Why we have done this? Because we need a more stable carbocation, and the OH is going to come and join in. So it is written as H plus H2O dilute H2SO4, or H3O plus is also written because H plus and H2O will have will form H3O plus. That is the hydronium ion. Okay, so this is going to be the mechanism. And acid actually help in breaking the pi bond, right? So this I hope is clear to all of you. Okay, so very simple question, but you have to be careful when you are using acid catalyzed hydration. Why you need to be careful? That I can make you understand by this question. So what's going to be the IUPAC name of the major product which is formed in this reaction? Yeah. Got my point?
Yes, sir.
So what's going to be the IUPAC name of the product? Yeah, Memuna? Vamsi?
So but 3-methyl 2 all.
Okay. Memuna, what's your answer? So you have put H here and OH here as per the Markovnikov rule, because this was CH2. Okay, so you added H plus to the carbon atom which has more number of carbon atom, and you connected the OH to more branched, because that is where the cation is going to form stable. But this is not the answer. Okay. Right? The answer is Vamsi and Memuna. This one. Okay. So what may have happened? Why this is the answer? Yeah. So what's going to be the answer? Yeah, okay. Now, Vamsi, what's the answer? Why this is
Sir,
the actual answer?
because the carbocation which is being stable, to become more stabilized, the positive charge goes to the tertiary carbon,
Yeah.
so that it forms a stable carbocation, and
Yeah,
hence
exactly.
most
Exactly. Yeah. Right. So the right answer is that first you will form a carbocation by adding H plus to the double bond. Double bond will come and take away the H plus will come and take away the pi electron density of the double bond. And now there is a migration of carbocation. The carbocation formed here is 2 degree, and if it can come here, it will become 3 degree. So, but how it can come here? We already have a lot of all the group present at this position. So, how it can come here? So, one group need to be shifted. So, who is going to get shifted? The one who is having more migratory aptitude, the one who can shift more easily, and that group is H. Then you have phenyl, more migratory aptitude, and then you have tertiary carbon, secondary carbon, primary carbon, okay, and then you have methyl. This is the migratory aptitude. So on this carbon you have two CH3 groups, and there is one hydrogen. So hydrogen is going to get shifted to this carbocation. And why do we need to shift it? Is there any incentive for doing this? Yes, because the final rearranged carbocation which we are getting is more stable. Okay, so the OH is going to attack on this carbon after rearrangement. So this acid catalyzed hydration of alkenes, it is Markovnikov of addition. But always remember Memuna and Vamsi, that it is with rearrangement. With rearrangement, if it is possible. Okay, if the rearrangement can happen, then it will happen. Suppose if the carbocation can become more stable, then we will do the rearrangement. We will form a more stable carbocation, and then we will put the OH group. Okay, so it is, so always check for the possibility of rearrangement. So Memuna and Vamsi, is there any other way in which we can do the Markovnikov addition of water on double bond and there is no rearrangement? Is there any way to do that? Yeah. So the IUPAC name is 2-methyl-butane-2-ol. Yeah, I was asking, suppose if I ask you to do the same Markovnikov addition, but do something so that we don't have rearrangement happening. So Vamsi, Memuna, can you tell me the method? Yeah. And the method is oxymercuration demercuration. Is it clear?
Yes, sir.
In short, it is known as OMDM. Okay, OMDM. Okay, this is the abbreviated name. Oxymercuration demercuration. And what's the advantage? Let me tell you the key point. It is the addition of water to an alkene in a Markovnikov way. That is Markovnikov addition. But we were doing Markovnikov addition from the last method also by taking directly H plus and H2O. What is the need for this method? The need is that in this case, the rearrangements will not happen. Okay. The rearrangements will not happen. Okay. So this is Markovnikov H plus. We're going to put on the carbon atom where more hydrogen are there, and the OH on the carbon atom which is having less hydrogen. Okay, more branch carbon you are going to put OH because that is where the carbocation is stable. So this is Markovnikov addition. And in the last case which we did in before this question, suppose, let me write it here. When we took simply dilute H2SO4, we observed that the rearrangement happened and the cation formed and it got shifted to adjacent position. But if we take oxymercuration demercuration method, and how do you add water by oxymercuration demercuration? What are the reagents? The reagents are mercuric acetate and water. The THF is the solvent to dissolve mercuric acetate and water, and followed by NaBH4 sodium borohydride. Okay, so if you take mercuric acetate, HgOAc whole twice, H2O, NaBH4, the same Markovnikov addition is going to happen, right? But without rearrangement. So Markovnikov addition, this is CH2, so we are going to add to this, H to this, and OH here. No rearrangement has happened. Is it clear? So have you noticed a difference, Vamsi and Memuna?
Yes, sir, can you explain it again?
Yeah, actually we are going to do the Markovnikov addition, but rearrangements will not happen. Is it clear?
Okay, sir.
The rearrangements will not happen. Okay. We will do the Markovnikov addition. For example, here we did the Markovnikov addition. We started with Markovnikov that H plus we started adding H plus to the carbon atom bearing more hydrogens. We formed a more stable carbocation, but that carbocation changed its position because it has undergone rearrangement. Okay, but in this case we will do the Markovnikov addition without rearrangement, no rearrangements. Okay, so remember the keywords, two keywords you can write, and those are Markovnikov addition without rearrangement. Okay, right? So yeah, so what's the mechanism? Let me quickly tell you, and why the rearrangement doesn't happen. So actually mercuric acetate breaks into the acetate ion, comes out, and you have a cation which is mercury. This is acetate. Okay, OCOCH3. Okay, in short I am writing OAC, OCH, double bond OCH3. Okay, so this is plus, this is the electrophile. Okay, this electrophile is going to go and join itself to the double bond such that a more stable carbocation is formed. The carbocation is going to form at this position. Okay, the carbocation is because it is more stable. But the difference is that this carbocation will not undergo rearrangement. What's the reason? The reason is once the mercury attaches itself to the double bond, mercury has a lone pair also. Once the mercury come in and take the electron, it has a lone pair and it forms a bridge cation. Okay, it gives its lone pair to the carbocation and let it remain wherever it has formed. Okay, so no rearrangement happen because it forms a cation like this. But this thing is just for your satisfaction. Suppose if you want to get into detail, but if you don't want to get into detail, the quick way to do that, always remember, you don't have to write the mechanism, but you need to remember the keywords, and those keywords are that with oxymercuration demercuration, you are going to have Markovnikov of addition of alcohol, Markovnikov of addition of water, okay, without rearrangement. Okay, no rearrangements will happen. Okay, because why rearrangements will not happen? Because this mercury has formed a closed cation, cyclic cation. Okay, but no one will ask you to write the mechanism. You can just go without mechanism, but you need to know the keywords and the main thing, the main purpose. Okay, is it clear? So let me give you this question and let's answer this question. What is going to be the product formed in this reaction? Krishna, understood? Maimuna?
Yes, sir.
Okay. So suppose what will be the answer? This question is asking the product of oxymercuration and demercuration. Okay. So you can answer this. And what would have been the answer of this question when you would have taken dilute H2S? For that also you can try. First do this, whatever which is asked, you can do that. Okay. And after that you can do the addition of simple dilute H2S. Okay. Yeah. So what's going to be the answer to this problem? Yeah.
So A.
Option A, correct. Right. Option A. Because just you have to add H and OH. That's it. In a Markovnikov way, H will get added to the carbon atom having more hydrogens, and OH will add itself to the carbon atom having less hydrogen. That's it, the answer. No need of doing rearrangement. But suppose this is another question. If you would have taken dilute H2SO4 to add water, what will be the product which is going to form in this case? So I added H plus, the carbocation formed on the secondary carbon, but the carbocation is not going to stay here. It is going to come just next to benzene. Okay, because that is benzylic alcohol and it is very stable. Why it is very stable? Because it can undergo resonance. It can get electron from the benzene. Benzene has a rich source. Benzene is a rich source of electron. It has 6 electrons, so the carbocation will get stabilized by doing resonance with the benzene. So the carbocation is formed at the middle carbon, but it is going to come next to benzene. Okay. So if you would have taken simply dilute H2SO4 or H plus H2O, the product which we are going to get is CH2H, CH2 and OH. This is going to be the product. Okay. That is the rearranged alcohol. Okay. Clear?
Yes,
But in
sir.
this case, with oxymercuration, demercuration, A is the right answer. Okay, good. Yeah. So, is there any way till now we have seen only Markovnikov addition in which we were adding OH group inside. We were having double bond, and because the inside carbon is more branched and if it is unsymmetrical alkene, we have seen that everywhere we were observing that the OH group was getting connected to the internal carbon. Okay, and that was what? Markovnikov addition. So first was Markovnikov addition with rearrangement, oxymercuration, demercuration, in which you take mercuric acetate and NaBH4 OH minus. That was Markovnikov addition, but there was no rearrangement happening. Okay, so is there any way to add alcohol in an anti-Markovnikov way? So what that method is known as? Yeah. What this method is known as? Vamsi,
So hydroboration oxidation.
yeah, hydroboration oxidation. And what you write it? What's the abbreviated name? It's by the name of a movie channel. Okay, HBO. Right?
Yes.
Okay. So hydroboration oxidation let you to add H and OH on the double bond in opposite manner, in anti-Markovnikov fashion. So we have seen anti-Markovnikov addition of HBr that happened in the presence of peroxide. Okay. So now we have seen anti-Markovnikov addition of water also. And coincidentally, this is also happening in the form of in the presence of peroxide. But you need to take something else also. So you take borane. Okay, this borane is BH3 and THF. Okay, why do we need to take THF? What is THF? THF is actually a cyclic ether. Okay, and this borane actually form a dimer. So borane actually doesn't if it is not taken in ether, it combines with its own molecule to form B2H6. In the presence of this ether, it remains a monomer BH3 because ether share its lone pair and let it remain as a single species. Okay, this is one thing. So always you will find BH3 THF written. So this is and followed by NaOH and H2O2. You take peroxide, but remember, okay, everybody, when I ask my students how you are going to add water in an anti-Markovnikov way, so all the students say in the presence of peroxide. Yeah, so they are partly correct, but they need to say what should be taken in the presence of peroxide. Okay, that is that. By taking peroxide in the presence of peroxide is not the complete answer. That is for HBr. For addition of alcohol, excuse me, you need to take BH3 THF. Okay, borane in the presence of borane in the presence of THF, followed by addition of peroxide and OH minus. That will give you alcohol in which the OH group will be connected outside to the outer carbon. Okay, one all. So always remember, whenever you want one all, okay, what you need hydroboration and oxidation method. This is hydroboration and oxidation. It has two names: hydroboration, oxidation. Hydroboration, this first step is hydroboration and this is oxidation. Now that's why it has two names, and I call it by a short form, abbreviated form, HBO. Okay.
So B2H6 is the product of BH3 and THF.
No, actually, no, it is not the product. Actually, borane remain B2H6, so you need to take it in the form of B2, BH3 in the presence of THF. It is one and the same thing. It
Okay,
remains in the presence of THF, it remains single. Okay, otherwise it forms a dimer, B2H6. Okay, and if it remains
Yes.
single, it can react, because we want the borane to go and react with the alkene. So we want that it to remain as single, and that happens in the presence of THF. Okay, so this is just a simple question. Which reagent will convert propene to propane 1-all? Memona, Krishna, tell me.
B.
Yeah, it is straightforward option B. Right, correct. It is hydroboration oxidation. Okay, and if you would have taken this method, this would have given propane 2-all. Okay, this would have not reacted, and this would have given propane 2-all, Marconi oxidation. And this method will give us propane 1-all. Okay, is it clear? Yeah. So what's the mechanism? So mechanism is, it consists of two parts. So first part is addition of H and boron. So boron and H go and get added to the double bond. But boron is a bulky atom, so it preferred to attach itself to the carbon atom which is outside. Okay, carbon atom which has more hydrogen. Is it clear? So it comes in and take the electron. Boron is an electrophile. Okay, I'm putting a box, empty box, because boron is having only 6 electrons, so it is an electrophile. It is an electron loving species. It is a Lewis acid. It can accept electron. Okay, when it was in THF, the THF was giving electron, but when it start reacting with alkene, the double bond of the alkene is going to give the electron to the boron. Okay, and that's how it get added. So its addition is not one by one, like H plus added, then OH added. Okay, actually hydrogen and boron add simultaneously in one step, and this is the way in which they add. I have shown you the mechanism. Okay, so this is the actual reason why you get OH outside, because OH is not attached directly, because if you attach it directly, it will get connected to the inside carbon. But you attach H and B, you attach B outside. B is automatically, it attaches outside, because it is a bulky. Boron is bulky, so it try to attach itself on the outer carbon. Okay, and this react with 2 more alkene molecules, so that you don't have to react, think. Just remember, if you want, you can 2 more alkene molecule to give you this. Okay, then what you do, you have this trialkyl borane. Okay, because this is formed by addition of BH3 on double bond, and it happens 3 times because BH3 has 3 BH bond and it can undergo addition 3 times, right? And that's how it has happened. And now you take NaOH H2O2. Okay, that actually oxidizes the boron and replaces the boron by OH group. So this is the shortcut trick. This is the trialkyl borane. Here it was the double bond which was initially present. Okay, you can put the boron on the outer carbon. and once you react it with NaOH H2O2, that inner carbon will get connected to, that was already connected to H, and the boron will be replaced by OH. So this you will have. Okay, this is the mechanism. Okay, so I hope this is clear, and this is the question, recent question from your JEE mains, but it is a very simple question. You can also have this question in your NEET JEE mains. Okay, yeah, very simple. This was from JEE mains. So what's going to be the answer to this problem? Yeah,
Sir, option D.
option A. Memuna, what's your answer? A and B are both Marconi propagation.
Yes, sir, same.
No,
this
sir.
is,
Actually, B is anti-Marconi compound.
yeah. Why we took hydroboration oxidation? What was the purpose? We were already having two methods of doing the Marconi addition. Okay. Actually, we wanted to convert the alcohol outside, and that was anti-Marconi addition. Okay. Right.
Yes, sir.
So we actually, by adding borane and by replacing that reacting borane with NaOH H2O2, what the purpose is? The purpose is to have alcohol on the outer carbon, and that is anti-Marconi. Is it clear, Memuna? Vamsi? So
Yes, sir.
A is going to be the Marconi addition. Okay. And while B is going to be the anti-Marconi addition, the answer for B is going to be this one. The double bond, I have put OH on the outer carbon, and the answer for structure, though they have not asked, will be this one. And suppose if you would have taken dilute H2SO4, then rearrangement will happen, and in that case your answer is going to be one methyl will get shifted, the carbocation will form here, the three methyls are there, they will get shifted, one of the methyl will get shifted to the C plus, and you will have carbocation here, and here you will have OH. Okay, here, so that is going to be the main answer, right? So this is Markovnikov, but with rearrangement, this is anti-Markovnikov addition. This is Markovnikov, but no rearrangement. And this is Markovnikov as well as rearrangement. Okay, this thing you need to remember. That's it. So let me move on to the next method for the preparation of alcohol. And that method is not only for the preparation of alcohol, but there are many other functional groups in the subsequent chapter which you can prepare by this method. Okay, and that is the preparation using Grignard. Okay, so Grignard reagents, what are Grignard reagents? They fall in the category of organometallic compound. What are organometallic compounds? Yeah, Vamsi.
Some metal halides.
Organometallic compound are those compounds in which the carbon atom is directly connected to metal. Okay, carbon metal bond. In organometallic compound. Okay, and there are many types of organometallic compound, right? For example, there is, suppose if you take CH3 MgBr. So in this, the carbon is directly bonded to magnesium. So this is organomagnesium. Organomagnesium means organo means carbon and magnesium metal. So this is Grignard reagent. You have organometallic compound as CH3Li. This is organolithium compound. You have CH3 whole twice CuLi. Okay. This is organocopper, means carbon copper bond. This is also known as Gilman's reagent. You have CH3 whole twice Cd, cadmium. Carbon is connected to cadmium. So this is also organometallic compound. Lot of organometallic compounds are there. Okay, let me ask you one very basic question. Which of the following is not an organometallic compound? More than one correct option. Which of the following is or are not organometallic compound? Yeah. More than one correct option. So what's going to be the answer to this problem?
Sir, option 3 and 4.
Yeah, option 3 and 4. Memona, is it clear?
Yes.
Because the oxygen is connected to Li. Okay. Na is connected to Li. Sorry, Na is connected to oxygen. So we need, for an organometallic compound, the basic criteria is you need to have carbon metal bond. A metal should have direct connectivity with the carbon. Okay. So the most famous organometallic compound which we are going to use in this chapter is this one. Not only in this chapter, in the subsequent chapters also. This is carbon magnesium bond, and how it is prepared. And this is okay. This is organometallic compound. So how it is prepared? So its preparation is very simple. The preparation of Grignard is very simple. What you do, you take alkyl halide, okay, and there are magnesium pieces of magnesium available in the lab. You put the ether, you heat and mix the magnesium, and you put alkyl halide. So that's how we are going to get the organometallic compound. What is happening actually? The magnesium is going to give you 2 electrons, and it is going to form magnesium 2 plus and 2 electrons. Okay, and you have alkyl halide. I'm writing it as RBr, and in the presence of 2 electrons, that is going to break as R minus and Br minus. Without the electron, it is going to cleave as R plus and Br minus. That we know because Br is electronegative, so it is going to take away the electron pair. R will have plus. But now you have 2 more electrons given by the magnesium, so that those 2 more electrons will go and get added to the R plus, and that will give you R minus. Okay, R minus and Br minus. Okay, and magnesium Mg2 plus. So all three of them club together, and what you get? You get RMgBr. Okay, so carbon magnesium bond. Remember one thing, you will be able to do each and every question. The magnesium will have plus charge, so carbon will have minus charge. Just remember one thing. If you can remember this thing, you will be able to solve all your problems related to Grignard reagent. Whether it is easy or difficult, you can solve it very quickly. Okay. And what's the trick? Always think that carbon is minus. Carbon directly connected to metal will have minus charge and the metal will have plus, because metals are electropositive. The electronegativity of magnesium is 1.2 on the Pauling scale, and the carbon is more electronegative. It has electronegativity of 2.5. Okay, so definitely the carbon, obviously it will have minus charge. Okay, so it is minus charge, because why you need to understand this? Because if you are doing any reaction, you need to know what the charge is, what the charge the carbon atom bears when it is connected to magnesium, and accordingly you will take your decisions while doing the reaction. Okay, so this is the Grignard preparation. You can prepare. You can take aryl halides or aromatic halide also. You can, but aromatic halide requires some more heating, because they are less reactive. Okay, so you can take the magnesium. You need to heat more than. Okay, suppose if you have two, which one? And if you put 1 mole of magnesium, so tell me where you are going to put the Mg, with whom you are going to form the Grignard. Yeah, tell me. Yeah, Vamsi.
So with fluorine,
Fluorine actually its bond is stronger. Being short, being smaller in size, it is going to overlap more strongly. Okay, is it clear?
yes, sir.
So Br actually is bit bigger and it is going to break more easily. So suppose if you, so ease of Grignard formation is RF is going to, so we don't prepare Grignard from alkyl fluorides. Then you have RCl, okay, RBr and RI. Okay. So because as you are going to have larger and larger halide, it is going to break more easily and the Grignard is going to form more conveniently. So the answer is going to be, because this question is asked many times. Okay. Right? This is going to be the answer. So we have prepared Grignard. So what we are going to do with it? Okay, there are many reactions, okay, which Grignard can give, and there are many reactions, but as of now we are bothered only about preparation of alcohols, which is the most important reaction also. So they behave as nucleophiles. They have a minus charge on the carbon. Magnesium is positively charged. Okay, it is having some covalent character also as well as ionic character also. It's neither perfectly ionic nor perfectly covalent. So R is having minus charge. So if it is having minus charge, so it will behave as a nucleophile. It can come in, and so I told you, you can solve all the problems of Grignard if you remember this thing. Just now I told you. Okay, so think of the minus charge on the carbon atom, which is directly connected to magnesium. Okay, so what this carbon will do? This carbon, suppose if you have taken aldehyde or a ketone. Aldehyde or a ketone, there the carbon has opposite charge. It is having partial positive charge because there it is connected to oxygen. And in Grignard, the carbon is connected to magnesium. So in Grignard, the carbon is having minus charge, and the aldehyde ketone, the carbon is having positive charge. So what is going to happen? Just think, this R minus is going to come and get attracted toward the positive charge. It is going to come in and join itself to the C plus of CO. Okay, and it is going to push away wherever the nucleophile goes in, because it is nucleophile is carrying its own electron pair with it. So R dash minus is having own electron pair. So it will push away some of the electron in order to make space for itself. So look what I have done here. So I have pushed away this pi bond on O that will have minus charge now. That will appear as O minus. Okay, clear? So R dash, and this can be an aldehyde or a ketone. I have represented in a general way, and this is how you can just neutralize it. Okay, so you can put water, so you will have an alcohol. Okay. So with formaldehyde, if you react the Grignard with formaldehyde, what you are going to get? This is the portion which has come from the Grignard. This is negatively charged. Vemuna, you can. The aldehyde can be considered as O minus and C plus. This minus is going to come in and join here. Okay. So you are going to have CH3, CH2, CH2 and O minus. O minus, the MgBr was plus. So put that MgBr with the O minus. That's what you are going to get. Put some water to neutralize this O minus and convert it to OH. So remember the conclusion, which is very, very important with formaldehyde. Grignard plus formaldehyde, what you are going to get? You are going to get an alcohol with one more carbon atom. Okay, this is a step up reaction. A step up reaction means you are increasing the number of carbon atom. And if you have a Grignard and if you react that Grignard with formaldehyde, you are going to end up with an alcohol, because this thing has come from this CH2H has come from formaldehyde. Okay, so this thing has come from formaldehyde, so you are going to have an alcohol with one CH2H extra. Okay, so if you want to make primary alcohol with one more carbon atom, use Grignard and formaldehyde or methanol. Is it clear?
Yes, sir.
Okay. But what happens if you take any other aldehyde? If you take any other aldehyde, what is going to happen with Grignard? Any aldehyde other than formaldehyde. Formaldehyde was having two hydrogens on both the sides, so that's why that CH2OH got added. Any aldehyde other than formaldehyde, what you are going to get? You are going to get a secondary alcohol. Okay, I hope this is clear. Okay, if it is not clear, do stop me anytime. You can ask me anytime. And if you take a ketone, you will always end up with a tertiary alcohol, because ketone already have two alkyl groups and one more alkyl group and come in and join on the CO. Is it clear? So methyl, propyl and ethyl came through Grignard. If you take dry ice or carbon dioxide, this will be used for the preparation of carboxylic acid. Dry ice or carbon dioxide has two doubly bonded oxygen, and while aldehyde and ketone were having only one doubly bonded oxygen. So this alkyl group is going to come in and join to the carbon. It will push aside the one of the pi bond to make space for itself. Okay, and you will have this kind of thing. So upon neutralization, you are going to get a carboxylic acid. Is it clear? So let me quickly review. Formaldehyde. With formaldehyde, you are going to get primary alcohol with one more carbon atom. With any other aldehyde other than formaldehyde or methanol, you are going to get a secondary alcohol. And with ketone, you are going to get a tertiary alcohol. Is it clear? Okay. So let's do these problems. Yeah. These are two different questions. First, try this one. Now, these are from JEE Mains question. JEE Mains NEET, very, very, very important portion. These questions are very important for JEE Mains and NEET, for all examinations, for boards also. Yeah. So what is going to, and this is the questions are not only related to alcohol chapter, but they will be related to alkaline chapter also. Yeah. So let's do it. So this question first, Maimuna and Vamsi. Yeah. Any idea what going to be the answer?
Just a second.
These both of these questions are from JEE Mains.
So HCHO is peroxide.
HCHO is formaldehyde, methanol. Peroxide will have 2 oxygen atoms.
So option C.
C, okay, let me check it here. Because this is OH, and when you react it with this, we have studied in that alkali chapter. Okay, this is PI3. Okay, when alcohols are reacted with phosphorus halide, you end up with a alkyl halide. CH3, CH2I. Is it clear, Memuna?
Yes.
And when you react it with magnesium, it is going to form MgI. Okay, that is the formation of Grignard. Okay, and this MgI will have minus, and this Mg is going to have plus. So what I'm going to do with this carbon minus, I need to look for some carbon which is having plus charge, and this is none other than the carbon atom of the formaldehyde. Okay, it is going to come in and join. Okay, ONS is going to form, right? And so what I'm going to do is HCH, CH2, CH3, O minus. Okay, this thing came through Grignard, and this portion came through the formaldehyde. And when I put water, it is going to get converted to OH. So it is going to be CH3, CH2, CH2, OH. Okay, so this is N-propyl alcohol of propane 1. Okay, yeah. So that's primary alcohol. If you want to make alcohol with 1 extra carbon atom, and that is still primary, you need to adopt this one. Okay, and now this is another question. Until now we have not discussed the concept of this question, so I thought okay, let's have it on the next page. So I decided to teach this concept directly by this question. This question is also from mains, and very basic question asked in all the examinations. So very important question, very basic question, and this is the type of reaction given by Grignard, but that I have not yet discussed. Okay, so by this question only we are going to discuss it. Okay, so let's do it first, then we will discuss it. Yeah. So Grignard is there, and you have given with an alkyne. Okay, and this is a new category of reactions. This is a different class of reactions given by Grignard. Very important. There were many questions related to this in NEET and JEE Mains. I just took this one question to make you understand the concept, basic concept. Okay, so Grignard, let me tell you, Grignard, whatever the carbon group is there, that is having a minus charge. Okay, and that minus charge can act as a nucleophile, which we have seen here. I will call it as a nucleophile if it goes and get attached to some carbon atom, giving its electron pair. Okay, but this nucleophile can also act as a base. So nucleophile and base, what's the difference? It is just like two sides of a same coin. Okay, they are two sides of the same coin. So CH3 minus is there. I will call it as a nucleophile if it goes and attack on the carbon. The CH3 minus, I will call it as a base when it goes and abstract H plus. Okay. So if the same thing goes and react with H plus, I call that thing as base. It need to have some lone pair or negative charge so that it can go and attach, abstract the H plus. But if that same molecule is not attacking H plus, it is getting connected to some other carbon, then I call it as a nucleophile. Okay, so Grignard can act as a nucleophile. That's what we have seen. We have seen the nucleophilic addition reactions of Grignard on aldehydes, on ketones, on CO2 molecules. Okay, yeah, and many more yet to come. But this Grignard can also act as a base. When it can act as a base, if there is a molecule which is having acidic hydrogen. So where the acidic hydrogen is, how you are going to know. And this is the fastest reaction. Okay, if you need to check whether there is acidic hydrogen. Acidic hydrogen is a hydrogen which is connected to electronegative atom, like water, in alcohol. Okay. So that acidic hydrogen, if it is there, the Grignard is going to come in and react with H plus and get neutralized, and it will give alkane. Is it clear? So that's the preparation of alkane. In alkyne, where is the acidic hydrogen and why it is acidic? Can you tell me? You must have studied in your class 11th. And there is one more thing, is the nucleophilic addition reaction going to occur on alkyne? There is a multiple bond. Is the nucleophilic addition reaction going to occur on it? The way in which we did on aldehydes and ketone? Or some other thing is going to happen? Okay. First of all, yeah, Vamsi, Memuna, would you like to add something? So first of all, nucleophilic addition reactions of Grignard will happen only on polar pi bonds. Look here. We were having polar pi bonds. So what do you mean by polar pi bond, Vamsi? The pi bond which is having partial charges. Yeah. Continue.
You said electronegativity differences.
Yeah, electronegative. So if the Grignard encounters any polar pi bond, it can easily come in and get attached to the positive end of the polar pi bond. There are polar pi bonds in aldehydes, ketones, okay, or CO2 molecule, what we have seen here. And there are polar pi bond in C triple bond N also. That is also polar. Okay. So there also the Grignard can come in and attach itself to the carbon bearing delta positive charge. So first of all, this is not a polar pi bond because the triple bond is between carbon and carbon. So both have same electronegativity. There is no charge separation, positive or negative, on this triple bond. Okay. There is another thing. Okay, so this is not a polar pi bond. On molecules with polar pi bond, we do addition reaction. But this is actually a special molecule. This is sp hybridized carbon, and we know it is more electronegative, significantly more electronegative than a normal carbon. Because of the triple bond, it's sp, and the electron pair want to remain close to the carbon, so it is very acidic. Bit acidic, not very acidic, bit acidic as compared to normal alkyl. So this H plus is acidic. Is it clear? Any doubt? acidic hydrogen. Okay, active hydrogen. We have active hydrogen on water, we have active hydrogen on NH3, we have active hydrogen on HCl, we have active hydrogen in CH3COO. And this is the active hydrogens, okay. But we have active hydrogen on alkynes also. Terminal alkynes have acidic hydrogen. Hydrogen of terminal alkyne is acidic because it is directly connected to carbon. But why carbon is not electronegative? We may think, no, it is electronegative because of its hybridization, sp hybridization. Triply bonded carbon is electronegative. Okay. So the Grignard, which is minus, doesn't find in this question, it doesn't find any polar pi bond to come in and join. Instead, it finds another kind of species which is H plus. So it will come in and abstract that H plus. Okay. So what we will get CH3 minus and H plus, we will get CH4 and we will have Grignard reagent on the alkyne. That MgX plus is going to come in with this C minus. So we are going to have a new kind of Grignard. Okay, so remember while preparing Grignard, okay, it's my personal experience when I was in working with some chemical industries. So you don't take any moisture, or should not be there. Okay, it should not be there any moisture, alcohol, because if you are preparing Grignard and if there are moisture or alcohol present, that Grignard is going to react with the water H plus of the water and it is going to come out as hydrocarbon. Okay, so you don't do you remain very cautious that you ensure that the ether which you are putting is dry, it is free from any water or any alcohol. Okay, so this thing is very important and most of the students make mistakes. So this is going to be the answer. Okay, is it clear? So okay, yeah, let's do this problem. No, it need a simple problem, but it need to be read very carefully because there are so many names written over here and you need to be very careful by dealing with so many names so that you don't make the mistake. Three methyl hexane, three all. I will draw the structure for you. There are 6 carbon atom, 1, 2, 3, 4, 5, 6 carbon atom. On third carbon atom, you have methyl group. On third carbon atom, you have all also, OH group also. 3 methyl, 3 hexanol or hexane 3 all is one and the same thing. So how it can be prepared? First of all, you need to take a ketone because this is a tertiary alcohol. Ketone has two alkyl groups already present on the CO and you can bring in one more alkyl group. So is 3-hexanol going to upon reaction with CH3 MgI and followed by hydrolysis going to give you? Let's check it. 3-hexanol is going to be this one. 1, 2, 3, 4, 5, 6. Okay, and if you react it with CH3 MgBr, CH3 is going to come in and get attached to it, but you need to make it a single bond. Okay, you need to convert the double bond as single bond, and upon hydrolysis you are going to get OH. Okay, so this is going to be the answer. Is it clear?
Yes, sir.
Right? Actually, this is not only one correct. This is one or more than one correct option. So is this the answer of this problem? Just check it and tell me quickly. Very important question. Very famous question asked in all examinations of all levels. So is this the set of ketone and your Grignard going to give you the alcohol which is being asked in the question? Let me give you one hint. On carbon, you have ethyl, methyl, and propyl. The shortcut trick is you can have any two group already present as on the ketone, and you can bring in the third group with the help of Grignard. Okay. So let's check it. Ethyl magnesium and 2-pentanone. So 2-pentanone is what? Pentane 2-one is this one. Okay. So you have methyl group, you have this propyl group already present on the ketone, and you bring in one ethyl group. This ethyl group is going to come in and join itself to this doubly bonded oxygen. So you will have one methyl which was already there, one propyl which was already there, and ethyl came in and joined O minus and OH. So are we going to get the same thing? Let's name it 1, 2, 3, 4, 5, 6. So this is hexane 3 all, 3 methyl, hexane 3 all. Yeah, we can get the same thing. Are we going to get the same thing with this? Yes. So butane 2-butanone is going to be this one. Okay, this is 2-butanone. And you bring, so methyl and ethyl are already there. And you bring in one propyl group. Because this is propyl C3H7. So is it going to be the answer? Let's check it. 1, 2, 3. I do the numbering from the side which is closer. Okay, 4, 5, and 6. And this is also same.